Assalamualaikum and a very good day to everyone. So today we will learn about the change rule for multivariable function. So at the end of the lesson, you should be able to apply the change rule to find derivative for multivariable function. And next, we can construct tree diagram to map out the relationship between dependent, intermediate and independent variable. Third one is compute second order partial derivative using the change rule. And the last one is we can solve implicit differentiation problems for equation with 2 or 3 variables.
Introduction. In calculus, when a function is formed by one function inside another, for example, x squared, we may have something like 3x plus 1 squared. So it's called a composite function. So when we have a composite function, we can use a special technique called the change rule. So for the first process, we need to break down a complex function into smaller parts. Then we differentiate each part, and lastly we combine the result systematically. The change rule is number 1. Okay. For function involving more than one variable, the change rule has several forms. So this one considers z equals to I, x and y, where x equals to gt and y equals to hg. So that means we have two variables in the function. This means that z depends on t indirectly, so we can write as z equals to f gt ht. So by using the change rule, we can then find the derivative of z with respect to t. So now we have the formula dz over dt equals to dz over dx times dx over dt plus dz over dy times dy over dt. So example number 1, we have the question: use an appropriate form of the change rule to find dz over dt. So we have z equals to 3x squared y cubed and x equals to t to the power of 4 and y equals to t to the power of 2. So for the first step, we compute partial derivative of z with respect to x and y. Okay, then we compute derivative of x and y with respect to t. So when we have these four, then we can apply the change rule by using the formula of dz over dt equals to dz over dx multiplied by dx over dt plus dz over dy times dy over dt. So we substitute what we get to the formula. Next. Then we can substitute also x equals to t to the power of 4 and y equals to t to the power of 2 as the question given. So for the first term, we get 6t equals to 2 to the power of 10, and also second term we get 9t to the power of 12. Then we multiply and add into the formula. You can get the answer is 42t to the power of 30. So for the next example, we have application case. The question give you a rectangle is growing in such a way that when its length is 5 feet and its width is 2 feet, the length is increasing at a rate of 3 feet over s and its width is increasing at a rate of 4 feet over s. So at this instant, the area of the rectangle is growing at a rate y. So sekarang kita keluarkan maklumat yang ada dalam question, iaitu L sama dengan 5, W sama dengan 2, dL over dt sama dengan 3 dan juga dW over dt sama dengan 4. So kita tahu formula for area adalah L darab dengan W, length darab dengan width. So sekarang kita differentiate dA over dL. So bila kita differentiate dA over dL, kita akan dapat W. Sebab apa? Differentiate L sama dengan 1. So 1 darab W sama dengan W. Sama juga dengan dA over dW. Kita dapat L. So sekarang ini adalah formula asal change rule. Sekarang kita gantikan dia dengan apa yang kita dapat sama dengan W dengan L itu. Jadi kita akan dapat dL over dt sama dengan dL over dt darab W tambah L darab dW over dt. So sekarang kita tinggal substitute maklumat yang kita dapat, iaitu 3 darab 2 tambah 5 darab 8. So akhirnya kita dapat jawapan dia iaitu 26.
Previously, we learned about the case 1. Now, let's take a look about the case 2. Case 2 contains 3 types of variable. Here, we have the 3 diagrams. So, how do we get these formula? Z over ds. First, we just follow the path from Z to X and from X to S, plus from Z to Y, from Y to X. That's how we get dz over ds. Now, how do we get dz over dt? Same goes, we just follow the path from Z to X, from X to T, plus from Z to Y, from Y to T. Here, let's test our understanding. The question given is Z equal to 4x cubed y to the power 5, x equal to 3s square d, y equal to 2s cubed d square. Find dz over ds and dz over dt. First, mula-mula kita kena lukis tree diagram supaya memudahkan kita untuk cari formula. Lepas kita dah dapat formula, kita just differentiate each side of the derivative. And bila kita dah differentiate semua, kita substitute semua balik dalam the chain rule. After kita substitute the derivative, kita kena substitute juga the x, y, supaya kita dapat answer in term of s and find the answer, kita dapat 72,576. S kuasa 20, T kuasa 13. Okay, lepas tu kita cari dz over dt. Macam tadi juga, kita buat tree diagram supaya kita dapat formula dia. Lepas tu kita differentiate each of the derivative. Lepas kita differentiate, kita substitute dalam chain rule. Lepas kita substitute, kita masukkan x and y supaya kita dapat answer in term of s and t, which is 44,928, S kuasa 21, T kuasa 12. Okay, since we master the case 2, now we need to learn about the general version. What is general version? The concept is same, no matter how many the variable is given. Okay, next. Let's take a look here. The function given W equal to f, x, y, z, and t. First, we need to draw the tree diagram so we get this formula. Okay, example 1. If W equal to xy plus yz plus zx, x equal to r cos theta, y equal to r sin theta, z equal to r theta. Find the value of dw over dr when r equal to 2 and theta equal to pi over 2. First, macam tadi juga, kita buat tree diagram supaya memudahkan kita untuk kita buat formula. Soalan dia minta dw over dr, so kita dah dapat dw over dr, jadi kita differentiate the derivative. Semua derivative yang kita ada, kita differentiate. And kan dia bagi R equal to 2, pi, theta equal to pi over 2. Lepas dia bagi kita substitute dalam apa yang kita differentiate tadi. Lepas kita differentiate and substitute, kita substitute semula dalam chain rule formula. Bila kita dah substitute semula dalam chain rule formula, kita dapat final answer 2 pi.
Next, we will learn about implicit differentiation. So for implicit differentiation, we use it when we have complex function. So if f is differentiable, we can apply case 1 of the change rule to differentiate both sides of equation with respect to x. So when we differentiate with respect to x, we will get df over dx times with dx over dx plus df over dy times with dy over dx equals to 0. So as we know that dx over dx is equals to 1, then we will get df over dx plus df over dy times with dy over dx equals to 0. Then we want to find dy over dx. So the derivative of df over dx and df over dy, we can move to the other side and it will become like this. Then we will get the formula of dy over dx equals to negative fx over fy. For our first example, the equation is find dy over dx if x to the power of 4 plus y to the power of 6 equals to 2xy. So for the first part, we will move all the numbers to the left side and we will get x to the power of 4 plus y to the power of 6 minus 2xy equals to 0. Okay. So because we already have the formula for dy over dx, then we will just need to differentiate our function fxy with respect to x and with respect to y. Then after we differentiate, we will get negative 4x cubed minus 2y over 6y to the power of 5 minus 2x. Then after we simplify and factor out what we get, we will get the final answer of dy over dx equals to negative 2x cubed minus y over 3y to the power of 5 minus x. But what if our function has 3 variables? So for our first example, we only have 2 variables, which is x and y. But for this time, we have x, y, and z. Actually, it is just the same concept. We will use the change rule and differentiate it with respect to x. Okay. So we will get this equation and we want to simplify it, which is dx over dx is equals to 1 and dy over dx is equals to 0. Then after that, we will get df over dx plus df over dz times with dz over dx equals to 0. Then we want to find dz over dx. So we will move the others to the right side. Therefore, we will get dz over dx equals to negative df over dx over df over dz. And it is just the same thing with dz over dy. We will just repeat the same method but differentiate it with respect to y. So this is the formula after we simplify our equation. For our second example, the equation is find dz over dx and dz over dy if x to the power of 4 plus y squared plus z squared plus 8xyz equals to 5. So, as usual, we will move all the numbers to the left side and make it our right side as 0. As earlier, we already have the formula for dz over dx and dz over dy. Then we will just need to differentiate our function with respect to x, z, and y. Then we will have our final answer for dz over dx, which is equals to negative 2x cubed plus 2yz over z plus 4xy. And for dz over dy, we have negative y plus 4xz equals to over z plus 4xy. So, in conclusion, this topic highlights the versatility of the change rule in handling multivariable function. By mastering 3 diagrams, we can systematically derive derivative for complex composite function, compute higher order partial derivative, and efficiently solve implicit differentiation problems for equations with multiple variables. So that's all from me. Thank you.